the symmetry that reality refused to keep. At first, the universe looked fair. Left matched right, forward mirrored backward. Symmetry felt like a promise. If the laws were perfect, outcomes would be balanced. Nature would not choose sides. Every process would have an equal reverse. Every structure a clean reflection. To understand why this mattered so deeply, we need to see how symmetry became a guiding belief in physics. Symmetry meant elegance. It meant that the laws governing the universe possessed a kind of mathematical beauty, a balance and proportion that suggested something deeper than mere regularity. It meant conservation. It meant that beneath complexity, the universe was impartial. If something could happen one way, it could happen the other. For a long time, this belief worked. The equations respected symmetry. Experiments confirmed it again and again. Space did not care where you stood. Time did not seem to prefer direction. Even matter and antimatter appeared as mirror twins. This created confidence. Symmetry was not just common. It felt fundamental, a rule so deep that violating it seemed unthinkable. If reality ever appeared asymmetric, it was assumed to be temporary, accidental, or incomplete. But then cracks appeared. Not large ones, subtle ones. Certain processes worked slightly better in one direction than the other. Some interactions favored matter over antimatter. Mirror images behaved almost the same, but not quite. The departures from perfect symmetry were so small that they could easily be overlooked. Yet they were real, reproducible, and resistant to every attempt to explain them away. At first, these differences were dismissed. Measurement errors, statistical flukes, noise that would disappear with better data. After all, symmetry was too central to fail. It was not merely a convenient feature of the equations. It was the organizing principle around which the entire theoretical framework had been constructed, and its failure would require a fundamental rethinking of what those equations actually described. But it didn't disappear. The more carefully physicists looked, the clearer the imbalance became. Small, persistent, unavoidable. Reality was obeying the laws, but quietly breaking the symmetry those laws seemed to respect. This was deeply unsettling, because symmetry was not just aesthetic. It was explanatory. It was the reason many rules worked at all. And now the universe was showing that it would not keep that promise perfectly. The symmetry that reality refused to keep was not shattered loudly. It slipped just enough to matter. And that slight refusal would turn out to be responsible for everything that followed. At first, physicists tried to protect symmetry by narrowing its scope. Maybe the imbalance only appeared in rare conditions. Maybe deeper rules would restore fairness once the full picture was known. Symmetry had rescued theory too many times to abandon easily, but the data refused reconciliation. The asymmetry was small, yet stubborn. No refinement erased it. No adjustment restored perfect balance. Certain processes simply preferred one direction over another, even though the equations allowed both. This created a profound conflict. If the fundamental laws were symmetric, why wasn't reality? Something was missing. Either the laws were incomplete, or symmetry itself was not as absolute as everyone believed. As experiments accumulated, the implications grew heavier. Without perfect symmetry, time could gain direction. Matter could dominate antimatter. History could unfold instead of canceling itself out. The universe could choose one outcome and suppress another. This reframed imbalance entirely. What looked like a flaw became a requirement. Perfect symmetry would have erased structure. Every particle would meet its mirror and vanish. Nothing complex could survive. No stars, no chemistry, no observers. Emotionally, this was difficult to accept. It meant existence depended on unfairness, on tiny preferences that tipped the scales. The universe was not neutral. It was biased, just enough to allow something to happen. The preference was so slight that it was barely detectable, yet it was responsible for the existence of every structure, every process, and every observer in the cosmos. By this point, symmetry had lost its status as an untouchable principle. It became a starting point, not a destination. Nature respected it approximately, then broke it selectively, where breaking it mattered most. The symmetry that reality refused to keep was not a mistake. It was a crack through which the universe escaped emptiness. The conflict deepened when physicists traced this broken symmetry back to the earliest moments of the universe. In the beginning, matter and antimatter were created almost perfectly balanced. Almost was enough. That tiny imbalance, one extra particle out of billions, survived annihilation. Everything else vanished into energy. What remained became galaxies, stars, planets, and eventually life. The universe did not need a large preference. It needed a minimal one. This buildup revealed a brutal sensitivity. Existence hinged on a microscopic violation. If symmetry had held even slightly better, nothing would remain. Reality depended on imperfection. As understanding matured, it became clear that symmetry breaking was not random. It followed strict rules. Certain symmetries broke, others survived. The universe was selective, not sloppy. It broke balance only where breaking it allowed structure to persist. Emotionally, this was unsettling. It suggested that reality was not inevitable, that the universe we see exists because of narrow tolerances. A different outcome was always possible. Nothing guaranteed this version of events. The universe we inhabit is a product of a particular pattern of symmetry breaking, and a different pattern, even a slightly different one, would produce a cosmos unrecognizably different from the one we observe. Yet physics also showed that without this refusal, there could be no history at all. No arrow of time. No separation between past and future. Symmetry would have locked reality into stasis. By this point, the role of broken symmetry was unmistakable. It was not a defect to be corrected. It was a mechanism, the engine that allowed difference, direction, and development to exist. The universe did not abandon symmetry completely. It violated it carefully, precisely, and just enough to make everything else possible. The climax of the story is a quiet but profound reversal. The universe does not fail to keep symmetry. It refuses to. Once this is understood, imbalance stops looking like error and starts looking like intention. Not intention in a conscious sense, but in a structural one. Perfect symmetry would have erased difference. The universe chose survival instead. This insight reshaped how physics interprets fundamental laws. Symmetry is no longer sacred. It is provisional. Useful, powerful, but not absolute. The deepest rules allow symmetry, then permit its violation where existence depends on it. More deeply, it reshapes humility. Reality does not owe us fairness. It does not guarantee balance. It enforces consistency, not equality. And from that selective imbalance, everything familiar emerges. Today, this broken symmetry quietly underpins the universe itself. It explains why matter exists at all, why time has direction, why complexity can grow instead of canceling out. The universe is biased, but precisely so. The symmetry that reality refused to keep was not a flaw in the laws. It was the escape hatched from nothingness, a tiny preference that turned emptiness into history. And once that is seen, imbalance no longer feels like a problem to solve. It feels like the reason there is anything to solve at all. The universe's refusal to maintain perfect symmetry was not a flaw in its design. It was the essential creative act that transformed mathematical possibility into physical reality. Subscribe to join the journey. The